So
okay, 31 participants.
Andrei, if you want to present a little bit yourself, we're really happy to have you. And thank you for accepting Alex's invitation.
Yeah, sure. It's good to be here with you. As I said, like, before we jumped in the earlier on the call, I wish I was there in Cluj in for today and for the JSHeroes conference as well. It's a shame that that's not going to happen that year. It's one of the fixed moments in my calendar, actually, the JSHeroes conference. So I'm pretty sad about that not happening. But on the other hand, it's really awesome. It's really awesome that you actually keep this this community going with this event. And I was like, when Alex asked me to join, yeah, I had it was a good opportunity, and I didn't want to pass down the opportunity to present again at JSHeroes. So I'm just a second. Let me stop my video. You saw me. I'm here. I'm not a robot.
Andrei, there's one more thing.
Yeah, sure.
Can you push the recording button?
Oh, it's not recording?
Oh, it's already recording. It's okay.
Yeah. Okay. Sorry.
Let me double check. But
I was expecting to be.
It's
yeah. Okay.
Perfect. Automatically.
Okay, thank you.
It says pause and stop, so I think it's recording. So yeah, this should have been my third time. Third time I actually gave a presentation at JSHeroes. This is one of them, and yeah, I always enjoy giving presentations to JSHeroes, and I really love the community and the people there. And Daniel was talking earlier about the survey being only for Cluj people. Well, I actually filled it in because I feel half a Clujer anyway, so it's not going to be an outlier if I filled it in. Yeah. So moving on. Yeah, I am Andrei. For those who don't know me or haven't been to one of my previous presentations in Cluj, I'm Andrei. Actually, sorry, just a sec. Actually, this is an old slide. We're doing. I'm not. Yeah. So I'm a front-end developer. Yeah, ever since I can remember, ever since I started writing code professionally, I've done front-end engineering. I'm currently doing consulting, and in my free time, I'm doing technical trainings as well for JSLeague, which I'll talk about in just a second. Yeah, I'm a JavaScript and web technologies enthusiast. I'm super hyped about everything that comes up in the JavaScript world. I'm also very passionate about UX and accessibility as well as the human side of development. That's also something I truly follow and believe in the humane part of development as well. And yeah, last and not least, I'm a perpetual learner because as we know, in this world of programming, you have to keep on learning. There's stuff that comes out almost every day, and yeah, we have to stay ahead of the curve. Also, in my free time, just a second, I need to minimize. Okay, that's it. In my free time, I organized Angular meetup group in Bucharest. It's called ngBucharest, and yeah, it's just your regular meetup group. We do like meetups, but with a focus on Angular. I'm actually planning on an online event for ngBucharest as well. I'm doing the final touches, so I can't announce anything official, but I'll give a link in the community once I have something for sure. So I was telling you about JSLeague. So on my, I'm a developer by day and a trainer by night. JSLeague is an initiative that came out of the Bucharest JavaScript community. We, came together and formed this organization, which on the one hand does enterprise trainings. So if you or your company needs a training, on JavaScript, let me know. But on the other hand, it also does a lot of nonprofit community events. For example, we had already two. We actually had two events, but I only highlighted the events. The events we actually managed to do in person. We did an intro to Docker and a testing workshop. So yeah, we tried to organize as many events. We actually had a lot of events like this last year. So yeah, this is what I do at JSLeague. Also, and I know Andrei is here really excited about this slide. We're not going to have JSHero this year, but fingers crossed that we're gonna have Revo, which is another awesome community-driven event in Timișoara, Revo.js. Call for papers just opened, so if you wanna submit a talk, I highly encourage you to do so. Yeah, if it's a great event. Check it out. It's Revo.js Revo.js.ro. Okay, so let's go ahead and talk about the topic that we gathered here today, which is the new version of Angular. So for those of you who actually work with Angular and or actually heard of Angular, you know that versions versions have been just a sec. Okay, someone was writing in the. I'm actually not gonna pay attention to the chat. Okay, so for those of you who followed the Angular world at any point, you know that versioning has been quite an issue and something that has been quite talked about, and that's why people make a big deal about Angular versions and the fact that it's 4, it's 5, it's 6, it's 9, it's 10, it's whatever. People actually get get really hooked up on the version thing. I actually know this. I actually been through this a lot when I'm discussing, training opportunities. People say, I want a training in Angular 7, and I'm always telling them I'll just do like an Angular training. It doesn't matter, what the version is, because it really doesn't, it really doesn't matter that much. But nevertheless, it's a good indication to know, what version you're talking about. And if you follow along with the Angular world, you know that version 9 was actually released about a month ago, about 2 months ago, actually. Staying at home for so long, I actually don't know what the date is, and I have no temporal feeling. So the new version of Angular was out, and it had a really rough birth, let's say. It had 13 RCs, and it had like a lot of moments where people were saying like, this is actually the final release candidate. I promise. In the end, I think it released at around RC 14 or something like that, but nevertheless, it got out. This is actually one of the, I think after Angular 2, this is actually one of the most important releases in Angular, and one of the main reasons why that is that with this version, there has been like a major redo of the rendering engine in Angular, like a complete rewrite, which doesn't mean that apps that you've written in Angular 8 are not compatible with Angular 9. That's definitely not the case. Like, this is not going to be one of those Angular 1 to Angular 2 not being backward compatible story. Actually, like, they're pretty much like 97%. What you've written in Angular 8 will be compatible with Angular 9, but there's so most of the changes are actually done under the hood. So this new rendering engine was actually available already in version 8, but it didn't. In order to enable it, you needed to enable it using a special flag. Now this new render, which is called Ivy, is actually enabled by default each time you create a new project with the Angular CLI. And the main improvement that this new render engine does is that it tackles the problem of build sizes. Angular was notorious, and one of the main points that people have been bashing Angular, besides the fact that it generally, because of TypeScript, it looks like a Java EE project. Each Angular project looks like a Java EE project. The other reason why people kept bashing Angular was that the fact that the builds and the resulting apps, so the final products, tended to be very, very large, and that's because mostly because of the way Angular compiled your code into browser compatible JavaScript. And we'll talk in a moment on the evolution of on the evolution of this rendering engines, but with this new iteration of the rendering engines, the problem of build sizes has been addressed. It hasn't been like fixed, but according to them, and because some improvements that they actually made to the rendering engine, people will see in the project, like the programmers were seeing in their projects quite some improvements. And we'll talk in a moment why, for example, you'll see differences for large apps and differences for small apps, but not so much for medium-sized apps. But yeah, nevertheless, pretty much anonymous. And here are some tweets, some screenshots with tweets taken from a few days and a couple of weeks after Angular was launched. Almost unanimously, people actually said that their app improved and it's doing better than it was doing before. And as you can see, bundle sizes tended to decrease, right, from 3.4 to 2.3 and so on. And there's actually like one of the I've seen this thread on Reddit about somebody talking about their apps having like even a 70% reduce in the final bundle size, which is quite impressive in some cases. I mean, this is a big win of first of all for accessibility and mobile experience and so on and so forth. Like being able to ship a smaller bundle. Yeah. So other things that now I'm just gonna talk about some of the things that got shipped in Angular 9 compared to Angular 8, and then we're gonna talk about Ivy and the rendering engine, and tell you more about why it's awesome. Why people keep getting this awesome result. So first of all, one of the things that got an improvement was the language service. So the language service usually is used in code editors like VS Code. So for example, if you go into the template, right, and you make data binding, right, and you start writing the name of a property of the class property that you're trying to do binding to, VS Code. So the editor will actually give you a hint about all the available properties, right? So this is actually done through the Angular language service. So it's not something that comes built into VS Code. This is actually something very specific to Angular, right? So the template here, the template HTML file, which is linked to the component file here, right? So as we all know, like a component is usually built, made up of the component class and the component template, right? And the template and the class communicate through bindings and events. Like, I'm not going to go into the theory of how components work really in depth, but that's the gist of it. So so the language service got a few updates there, and I think yeah. So there is a property. I actually didn't. I think it's strict. Okay, I didn't write this down. So there's actually a property, but I can't remember what the property name was here, and I didn't write it down. There is a property that you can add to the TypeScript config file that would actually do a more stricter check on the properties that you use in your template. So that's something that was actually improved for this version. I can't remember the property right now, but it'll come back to me, and I'll write it down. Another thing that got a bit of a change was the way that we tell what the scope of a service is. So when we declare a service, starting with version 6 of Angular, you can actually give the injectable decorator, right? This injectable decorator tells Angular that this class here is not just a simple TypeScript class, it's actually a service. So this decorator here had a property which is called provided in, and we can actually tell Angular here where this service will be used. If we use the standard property, the root property, which is the default one, means that this means that the service here will be a singleton and will be available to all the all the eagerly loaded modules in your to all the modules in your application. But also, there have been two other properties that have been added as options. So the any and the platform and the platform options. The thing with the any service is that, for example, if you add a service in a lazy loaded service, as you see here, right? You get an instance of a service for each lazy loaded module. If on the other hand you configure this service with the any property, this service will be loaded. You will not get an instance for each lazy loaded module. Instead, you will get one instance that will be available for the entire application. So there might be some scenarios where this might come in handy. And platform is another property that you can give to the provided in property here. And it's a more advanced scenario. For example, if you're using an architecture that has or an application that has more Angular applications. So for example, you're doing micro front ends, or you're using Angular elements, or some more advanced scenario. Angular elements is a way that you can build Angular components and serve them as web components. So you can actually use this provided in platform and actually share services between different applications of Angular. So this is something new that was introduced in Angular 9. Other things that got added. So no need to. So for example, for viewchild. So when you wanted to refer to viewchild is a way to refer to elements in the template. So if you want to grab hold of an element from the template and use it in the class, you would normally use this. You would create a property and you would use this decorator here for viewchild. And this decorator here had a property that was before Angular 9 was mandatory static files, which is now not needed anymore. I mean, it's not necessary to specify it anymore, because this is actually the default. Also, TypeScript 3.7 support was added. Actually, I think a couple of days ago, Angular 9.1 was released, and they actually bumped up support to TypeScript 3.8. So you get a lot of extra goodies for new versions of TypeScript, like nullish operator and so on and so forth. Also, there were some improvements to the testing module. So for those of you who actually done some testing at some point, this is the one. For example, if you had, like, this is a regular Angular test file, and for example, if you wanted to use a service in your test, right? So you would, for example, we have this settings, the settings service, this settings service here. What you would normally do, you would actually use this test bed, which is the the configuration module for your test that gives you like everything you need in order to run the test. You would actually use this method here, which you see now it's deprecated, and you will get get the service. The only problem with this method is that this is not a type safe method, so it will not return the exact type of the service. So what actually happened is that this method got replaced with inject, and inject is now type safe. So now we know that service is of the required type, right? So if we want to actually check this, we see that we have the properties for the corresponding type. So this is also something that was added in this new version. And also one of the most awesome things that got added in the in this new release of Angular. Let me start this the demo application real fast. Is the ability to debug your applications. So some extra debugging capabilities from your browser. Just a sec. So let's see if this works. Okay, so this will be the component that we are working with today, and it's a very simple component. Like template wise, it's pretty simple. Like you have these two buttons, and the volume goes up as you press the up and down, goes up and down depending on the buttons that you press. So the template is actually pretty simple, like it's what you would imagine, and the class is simple as well. Like it has 2 methods, and there are just some simple checks so that we don't go, we don't overflow the volume indicator. But other than that, it's really super easy to follow components. So it's really, there's nothing really complex going on here. So one thing that you can do is you can actually right click on this component over here. And now the component is, oops, sorry. Where's the, oh, here it is. So now that we, okay, now that we selected the component, right? This is the component in our template, right? We can use we can use the Chrome DevTools helper. So $0 gives us the selected the currently selected element in our template. And what we can do, we can actually use this new ng property that is globally available in our applications while we are in development mode. And what we can do, we can actually say ng, and we have a lot of methods. And for example, we can actually get the component and pass $0 to it, right? And we can say right? And now we actually have the component, right? We got a hold of the component instance, and you can see all the properties. So for example, if I say component volume, which is the volume indicator, which right now is 100, but it's actually 50% because max volume is 200 and the current volume is 100. So for example, if we were to say like the volume is 140, right? Nothing happens because we still have to say ng apply changes and component, right? And as you see, the changes got applied. We actually have to do this in order to tell Angular that something changed in our application. So basically, apply changes triggers change detection cycle. So yeah, and what else? Yeah, for example, we can also do something like get the event. Oh, sorry. For example, we can get the event listeners that are attributed to HTML elements. So for example, we have this button over here. So that's $0 now. So if we say ng get listeners, right, of $0. Let L, right? We have, right? We now have an array of listeners, right? And we have the callback, right? The callback of the listener. So actually, if we say L of 0 dot callback and we call it, we should. Right, you saw that things change. So there's a lot of things that you can actually do now to debug your application without having to go into the code and change something and then come back and reload and refresh and lose your state and something. So this is one of the things that for now is just sitting here, but it could be used, and it could be something really useful to use for other debugging tools that might be developed. So yeah, this is just a highlight of stuff that got updated in Angular 9. What I was telling you about is the changes. Usually, the changes that come from one version to another are mostly done under the hood. The API actually hasn't changed that much since Angular 2, which was like the biggest. Actually it's new Angular 0.1. Angular 2 is actually new Angular 0.1 because it has almost nothing in common with the old Angular. But from one version to the other, actually not a lot of things changed in terms of API. Like if you started learning Angular at Angular 2 or Angular 4, and then you took a break for like 2 years and did something else and then came back, and you started looking at Angular 9 code, it will not seem that that strange or different. Like what I showed you now is actually like, you know, really small changes in the API, breaking changes, because that's why you know, the major version got bumped. But nevertheless, the API usually stays pretty you know, pretty consistent. I mean, this is the way you wrote components in Angular 2 as well. Like this is, you know, I'm actually looking to see if there's anything here, but this is actually Angular 2 compatible. Like if you took this code and put it into an Angular 2 application, it will run. And that's one of the things that I'm generally excited about when it comes to Angular, because number one concern for the Angular team is to assure that you know, each release of Angular is backwards compatible to as you know, to as much of an extent as it's humanly possible. And there's two reasons for that. First of all, Angular is used a lot, and I mean a lot, in hundreds of projects in Google. So when they make a change, if they break something really bad, they have to fix, like the Angular team actually has to fix everything in, or like, you know, they'll have a lot of backlash from their colleagues at Google. So they have to be really careful about the way they do changes. That's one aspect. And the other one is that, you know, as you probably know, Angular is used a lot in enterprise scenarios with, like, you know, really big projects where migrating from one version to another is not always super you know, super simple. So they have to make the big challenge for the Angular team is that they have to you know, make improvements and bring news, always, like, you know, bring new stuff and improve the performance and bundle size and everything. But they have to do this in in very, very strict limitations in terms of things they can play around when it comes to the API. And a lot of the things you know, a lot of the things that I talked about are actually changes that you can automate. Like, for example, the provided property, or the fact that, you know, you don't need strict false anymore, or, you know, some other things that we'll talk about. For example, entry components. I'm going to talk about entry components in just a second. They actually just became deprecated. Like, they're not going to be needed anymore. You can actually automate this really easy. And the Angular team actually has a really good, I think it's Angular upgrade. Yeah. So there's actually this website that is provided by the Angular team that gives you instructions on how to migrate from one version to another, right? You can actually go from, like, even from version 2 to version whatever. So for example, if you want to migrate from version 8 to version 9, it actually gives you like a number of steps. And there might seem like you know, a lot of things to do, but it's actually not that much to do. Like, all you need to, like, the basic thing that you need to do in order to have a safe update is actually to run the update process from your CLI. Like, first of all, of course, you need to, you know, make sure that you're on a good version of Node. Make sure that your Angular CLI is up to date, and then you just run this command, which is, you know, an Angular CLI command, and a lot of the things are done for you automatically. And this has been the case, for example, from migrating to Angular 7 to Angular 8. I think from Angular 6 to Angular 7, they actually changed the version of RxJS from which is an Angular dependency. They changed it from version 5 to version 6, and they had a script to migrate versions from automatically migrate your RxJS 5 code to RxJS 6 code. So this is, you know, one of the things that tells me that the Angular team is really, really caring about people that use their framework, and they want to be as helpful as they can, so that people, you know, manage to have a smooth upgrades. For example, I remember reading an article from some airline company. Was it KLM, or I can't remember, like some big airline company that actually wrote an article about the fact that they migrated their website, which was written in Angular, and it's a really, really big and complex website. Like the airline bookings one are usually really complex, and they migrated from Angular 7 to Angular 8 in something like a day or something like that. So that's you know, one of the things one of the things that makes me really glad about the work that's being done by the Angular team. Okay, so yeah, as I said, this is the the basically everything you need to do for your average project. This should be mostly 80% of the work. For extra details, like I have a lot of links in the presentation. Feel free to check them out as well. Yeah, there are other changes as well that I didn't, like we talked about, for example, the test bed, and I told you about any components. But other than that, there's not that many changes in terms of API. There's some deprecations, but in terms of API, it's not that that big of a change. The big change and the most important change is Ivy, which is basically taking taking your average, your regular engine from your car and changing it with like a V8 or something like that. I'm exaggerating a bit, but the experience is it's something that you can relate to, right? I mean, you will still be able to drive the car, the pedals will be there, the gearbox will be almost the same, but your car will run faster, and you'll probably impress more people with the roaring sound your engine makes. But basically, that's in a nutshell, that's basically what you need to understand about Ivy. It's basically changing the engine in the car. Everything else mostly stays the same in terms of your experience with the car. But because the engine changed, all the wiring needs to change as well, and everything else. But you won't feel the difference. This is the main things that make Ivy great. And Ivy, this new render engine that we're gonna talk about extensively in just a moment, is not necessarily just about Angular 9. It's about Angular, the future of Angular. It's about version 10 and 11 and 12 and everything that comes after it. The Angular team has been working on this for like a year and a half at least. Like it's a really big change in the way Angular works, and I think it's comparable to what the Facebook team or the React team at Facebook went through when they were developing Fiber. Like I remember. when back then when they were developing Fiber, that almost everything was on halt. Was like, we have to finish Fiber and then we'll focus on other stuff like suspense and whatever stuff they were like, context and whatever else they were working on. This is what happened with Angular and Ivy. Like almost everything else was put on hold so that they can ship this this renderer. And now that this renderer is out, is the default rendering engine that you will get for your applications, and up until version 10, it's basically gonna, they're gonna do bug fixes and make sure that everybody is okay with this new release, and there are no problems, and all the edge cases most of them are fixed. The Angular team can start focusing on, making this, making the framework even better. I know there's like a lot of discussion. Like I follow the discussions on the Angular repo page, the GitHub repo page, and I know there's like a lot of discussions on improvement in the forms module, which is already great. I would argue that it's like the Angular forms module is like the best way you can do forms in all, like in the major frameworks right now. But still, there's like a lot of things that can be improved there as well. And now that Ivy is there, it actually, Ivy is an enabler for what's to come in Angular. So yeah, that's the selling point for Ivy. Okay, a bit of history. So Angular 2 launched in 2016. Man, it's been 4 years already. Wow. Anyway, when it first launched in September, if I remember correctly, it was September or November. Anyway, it was autumn 2016. The first version of the renderer was the template compiler. That's how what it was called. And also Angular 2 came with ng modules, which we'll talk about in a moment. But basically, besides the fact that it was a completely new framework, those were the highlights. Then Angular 4 came into 2017, and yeah, so there was no Angular 3. For those of you who don't know, there's like a really long story there, but I'm not going to go into it. But anyway, when Angular 4 launched, the rendering engine was rewritten. It was the first rewrite of the rendering engine. Again, not a lot of change at the API level. Like people didn't feel get to feel you know, the changes, and upgrade was pretty much smooth. Also, animations and the new HTTP client got introduced, but it was basically like, you know, mostly incremental additions to the framework. And then almost 2 years later, in Angular 8, Ivy, which is the third version of the renderer, got launched. And in Angular 8, as I told you in the beginning of the presentation, you could actually, through a flag, enable Ivy in your application. So this is, you know, just a brief history to see how this rendering engine evolved in Angular, right? So why I mean, I kept using this notion of and I'm talking about like compiler and renderer and so on and so forth. And now I'm gonna try to you know, make you know, use the terms correctly and talk about each of them. So why do we need a compiler in Angular in the first place? So basically, as I showed you earlier, we have templates which are declarative. It's basically HTML on steroids, right? It's you know, your average HTML elements with some sprinkle of Angular specific code onto them. Of course, those templates are not, the browser cannot interpret them because they are super specific to the way that Angular works. So what we need is to transform those templates, right? That HTML template, we need to transform it into JavaScript code that runs in the browser, right? So that's why we have a compiler, and the compiler is called ngC, right? From ng, which is usually the abbreviation for Angular, and C from compiler, right? So basically, what the ngC does is take this template over here, which is, as I said, you know, average HTML tags sprinkled with something special from Angular. And this is, for example, the interpolation. And in here, sorry, just a sec, title. Yeah, makes more sense. Oops. Oops, sorry. Live editing. Okay, back. So right, so this is the interpolation expression in Angular, and this marries this property over here from the class. It marries to this property here from the template, right? But this is something that we see and use, and the decorator and so on and so forth. It's something that we use at develop time, right? The browser has no idea what this is, how to interpret this, and so on and so forth. So that's why, although we develop code like this, we actually need to get it through a compiler and get code that the browser will actually understand. And this is usually JavaScript, right? So we transform this class over here into something that the browser understands, right? So, you know, to sum up, we need this compiler to, you know, to transform the Angular abstractions. Also, we need to, you know, our components are not only going to be static HTML. We'll do some manipulations on the template, and we also need to have that into the JavaScript code, bindings and change detections, and also, you know, we have styles and animations and what have you, right? So that's why we need a compiler. So the compiler is half of the story. This process, as you can imagine over here, doesn't need to be, you know, there's a special way that you can ship code to to the browser that is called AOT, which comes from ahead of time compilation, which means that all this code over here that you saw is compiled before, you know, when you run ngBuild, this code over here is is compiled already. So, you know, this, you know, extra information doesn't need to be transferred to the, you know, doesn't need to be transferred to the browser, right? So the compiler actually is only, but using AOT is only something that is used at develop time and build time. So when you do the build, at the Angular compiler is used, and then is this you know, disregarded. And what is used to
well, let me ask you this: what are you going to go do now? What if Daisy or someone is already
I think somebody unmuted the microphone.
Yeah. Can everybody just?
I don't want you to do any more fighting.
You can mute.
I can mute, right? Let's see. Unmute. Let's see who's.
You can mute everybody.
There we go. Okay, everybody's muted now. Okay, coming back. So that's why I said the compiler is only half of the story. What gets shipped to the browser actually is this Angular runtime, which is the code that is used to interpret that compiled code that we saw. So it also, if we look at the evolution of outputted code, this is what you know, a very simple component used to look like in the you know, in the compiled version of the template compiler. And there's like this code over here. It seems like a lot of code, but it's super highly efficient code. Like I've seen a presentation from one of the tech leads from Angular, and they were talking about, like, you know, optimizing to V8 you know, engine, JavaScript engine level, and you know, using a lot of you know, tricks, as you know, using arrays versus using objects to enhance the speed of access. So that's why you see like a lot of like, for example, here you see some arrays and so on and so forth. But still, you had this problem. Although the code was fast, and Angular, like, don't let anyone else tell you otherwise. Like, Angular is a really fast framework. Like all three major frameworks are fast. Like, there's no way you know, you can say that one of them is faster than the other. And Angular is fast. But the problem is that you had a lot of code that got generated. Like, this is the template compiler, so the version 2.1. Things got a bit more, you know, got improved a bit in the view engine. So, you know, that's the same code that the same component that you saw earlier, but then, you know, you had like around like a half, let's say, reduction. And this is, of course, unminified code, right? So when we're talking about minified, actually the gain is not that much, but nevertheless, code was simpler, and you can actually look into the code, and you can start, you know, figuring what's happening here. So for example, you see that there's an end line here, and okay, so there's an element definition of div. Okay, I can understand that. There's another element definition of h2. Okay, I can understand that too. And there's another text with hello, and then the h2 ends. And you can actually look at this code and, you know, not perfectly understand. Like, for example, like I have no idea what all these nulls are. I just know like there's some properties and whatever. But you can, it got a bit more, you know, the outputted code got a bit more debuggable. But this is actually like what is yeah, and this is actually like the version that we are at now, the Ivy version. And I'm sorry about the fact that this is actually okay, this is actually minified code, but I'll show you in a second on actual code how this looks. But in the end, what happened is actually like, you know, the code got way cleaner, and things got way more, you know, you got way less code that will be shipped to the browser, and that's the most important part. But also debugging is really improved. And if I were to show you an example, like I have here a sample application, like this application uses Angular 8, right? 8.2. I think it's the last 8 release. And when you compile this code over here, what you can see is, right, you have this, you have all these, all these properties and nulls and whatever. So this is, the resulting. I'm not going to go into detail, but it pretty much looks similar to what I showed you earlier. So the component is actually like, really simple. It's just an H1 with the title. But as you can see, there's like a lot of files that got generated, right? So this is the view engine pipeline. So what actually happens in this pipeline? So you have these are usually the 3 files that you use in your project, right? You have the TypeScript file, which is the component class. You have the template, and you have the styles usually of the component. So that template, goes through all these pipeline, which I'm not gonna discuss right now. But it's like, it has to, basically extract the information from the decorator. It actually has to interpret. It has to extract the data from the template. It has to interpret the decorator data and everything else, and then it takes out some. It spits out some instructions that can be used to render DOM. And you have all these files. So basically, for each component, you have a definition for the component. You have a factory. You have a metadata JSON, and you have an ng summary JSON. So there's like a lot of files that get generated for each component, right? So basically, the factory, the ng factory, is the file that is used, as the name implies, is used to build components afterwards. And one of the things that happened with, so just to stay with the view engine just for a bit. So for example, if we have, like, as I showed you earlier, like this really simple example of a template, right? The generated code, so the code that got generated in Angular, right, told you that, like, you have an element definition, and which is the div here, right? It's a div with a class of greeting. Like, you can make some sense of what's going on here, right? And then you have a text definition. So basically, we'll talk about the idea behind the DOM, generating so basically transforming this DOM into instructions, and how what's the technical definition for this. But basically, this is what's happening. Like, you just take every line, if you want, from this template, and you transform it into an instruction. The problem here, so one of the problems why the resulted code in the end is pretty large, is that if we look at this is pseudocode from what the function to actually create the node looks like, is that it looks something like this. Actually, it's if we look at it, it actually has a lot of if statements in it, right? So all those Angular uses like a lot of codes and numbers and bit operations, because it needs to be fast. So when you try to render or one of these nodes, the functions usually end up looking something like this. Like, is that is that function being called on an element, or has that element is it a container, or does it has Does it have pipes or whatever? So there's like a big switch. And actually, if we look at the source code, you can see this pretty clearly. Like it actually uses like a really big switch case over here, right? So, and the problem with this, the way the functions are written in the old engine and the fact that they use all these flags and switch cases is that in the end, the engine code cannot be tree shaken, and that's a big problem. So basically, if you, for example, are not using the, so yeah, let's talk a bit about what tree shaking is. So for example, if you have on the left side, if you have a module that exports two functions, right? So function f1 and f2, and in your main code, you only import f1 and you use f1. Only f1, the function f1, only this part of the code actually gets shipped to the browser in the final code. This function, because your code bundler, like be it Webpack or Rollout or whatever other code bundler, can figure out by statically analyzing your code, can figure out that this function here is never used, right? Because you only import f1 and you don't use this module anywhere else in your code, and that means that it's safe to assume that this code should not be imported in your application, right? So it's basically, it's tree shaken. But on the other hand, for example, if you have this scenario over here where you import, it's import f1 and f2, and you definitely use f1, but f2 is used under a condition, right? And you have no idea if this condition will ever be true. Like it could be if the year is 1970 or something like that. So you can have there in there something that will always be false. It's impossible for the code bundler to figure out that f2 will never be used. So f2 actually gets shipped to your final bundle, even if in the end it doesn't get used. So this means that f2 is not tree shaken, right? So that's why, because of the way, sorry, just a sec. That's why, for example, in this code here, in the way the engine is written, like it doesn't matter what this function actually does, but this is the way most of the functions are written in the engine, because we have this switch statement here that looks for these flags to see if this is the code that should run for a type element or for a text or for whatever. All of this code, even if we only use this part of the code in our application, right? Only if we use this part, everything will get shipped, right? Because we have no idea. Like, for example, we reference this create text function over here, or we reference this create provider instance, or this create pipe instance, which, you don't have to understand what they do. But what you need to understand is that even if you don't use pipes in your application, this code will still be shipped, right? So that's why bundles in Angular tended to be large, because you shipped almost everything, because there was no way for Angular to know at build time, right, at compile time, if your code is going to use one feature or the other, because of the way these code instructions over here were written. This changed, like what I just told you, changed completely in Angular Ivy, and now you have, this is the same, right? So you write your components and your templates and your styles the same, the almost exact, like 98.7% the same as you used to. But now under the hoods, like the pipeline is way more simplified. And what you get in the end is just this single file, which if we look at another project, like this is, so this is the version 8, right? Which gave you like a factory and a metadata, which is, the, analysis of the, of the decorator data and so on and so forth. So you have all these files. Like now, if we look at the version 9, which is right, which is the same component, right, minus this app volume over here. If we look at it, right, we only have this app component.js, right? and the text, right? And the code is super, super simple. It's even like you can look at it and you know, you probably can't understand everything that's going on here, but you can make some sense of, like, if we put it you know, to the side, we can actually have a look at it and see, okay, so we have our up component. Okay, this is the title and this is the condition. Like I can understand that because this is how my component class looks, right? Let me put this here. Right, I have this title and this condition, like, and this is, you know, this is my class. Okay, I can understand that. And now I have a factory function, right? A factory function, a static property, and another static property that's called CMP, right? Which uses this define component method, which again, it's not necessarily super important what all the details, but you can look at it and see, like, okay, element start H1. Okay, this is the H1, I can understand, okay. And there is a text in there which has some binding, right? So this is like the theta theta text over here. Okay, I can understand that too. And then the element ends, like H1 ends. Okay, that's pretty straightforward. And then we have the second part, and we'll talk in a moment about the second part as well, which takes care of the change detection part, right? So it actually tells us that we have on position 1, which the 1 here is the corresponding for the 1 over here. We have this text interpolate, which says that we have to link to the context, right? The context, which is the class, we have to link to the title, and this code will be run each time there is a change detection, right? So without, you know, going further into details about what these mean, these are this is the way that things are written right now. And the main difference is that now actually this component function over here will directly call these function over here, right? So it won't, there won't be like a method with a switch on it and flags and what have you. The component will actually say what it's using directly, and if it doesn't uses something from the framework, it doesn't call that function, and then that function, because it's tree shaken, right, because it isn't called anywhere else in the code, it will not end up in your final bundle, right? So this is one of the major things that happen with this new render and the new way that code is written, right? So no more ng factory files. And actually, because there's like, for me, it was super puzzling. Like until later, it was later in my Angular days, it was super confusing what the ng factory file was and what the metadata JSON file was, and you had all these in directions and terms, and it was really difficult to to really understand what was going on, because there were a lot of terms and a lot of concepts, and Ivy actually simplifies a lot of what's going on. So let's take this, the example with the component that we had earlier, and let's see, what's going. Let's retake it step by step what we just talked about. So this here is the component code, and this is what gets generated when we compile, right? And this is the part over here. This is the part that is responsible. The blue square is the part that is responsible for the template compilation process, right? So it has two. This template compilation phase has compilation process. Is translated into two phases. The creation phase, which is the code that is that runs the first time when the DOM element is created. So when the component is instantiated and attached to the DOM, this is not attached. Will be like we need to compile DOM code that will be attached to the actual DOM. This is the part of the code that will run, and it's as I told you earlier, it's just a description of instructions to recreate this template over here, right? We say, okay, we need to start an H1, we need to put a text here that will bind to later, and then we'll end the tag. And the other part is the update and change detection phase, which will run each time Angular is signaled that something changed in our code, right? And what's awesome about this is that app component, if app component is the parent component of user component, a widget component, app component doesn't need to have any data regarding, or doesn't need to know anything about user component or widget component. It can just call because each component has its own function to create its own instruction sets for the template. Each component can call other components factory functions, and that's everything it needs to know. It doesn't need to supply it with anything else, right? And so we saw there, really simple example. There are actually other instructions we can use. Like we have like element and text, but we can also have a template or like projection for when we do like content projection, or like have a listener or a pipe, or for the translation library. But we also can use like these are usually like bindings that we can use on the elements. Like for example, if we use like attribute bindings, this will be the function that will be used, and so on and so forth. So if there's something in our code that we don't we don't use, these methods will not be called, right? So if we were to look like at a more complex example, like this is a simple example. Like as I said, like it has an element start, a text, and then an element end. For example, we have also we have if we were to have like an attribute binding, this will also be will also be included in the instructions, right? The order, like I can't really explain that well, why the order of the instructions is not necessarily in the same in the same order. Like there's some theory about it, but like bear with me. What you need to understand is that everything in the template will generate an instruction, right? So here you have, for example, you have a style binding. Here you have like just an attribute binding, right? An attribute to the tab index. And here you have like a style attribute, which triggers uses two other methods, like the styling and style sanitizer, right? Because we need that so we don't have weird style strings. Yeah. So to sum up these one of the main things in the new Ivy compiler is that the component actually calls the framework. It's not the framework that uses the component, and there isn't the component actually is the render engine itself. Like it doesn't need to, like it calls some methods, that's for sure, but it doesn't, besides the methods that these components call, there's not much other magic than than this. Of course, there's like a lot of methods that are being called, but usually the component itself, and by the fact that it's using the framework, doesn't need is self-fulfilling, let's say. Okay, so I told you earlier that I was going to tell you about all these, why Angular went with this way of taking the templates and transforming them into instructions. And here Angular is using something that is called incremental DOM. And incremental DOM is something different than virtual DOM. Like, and I'll explain both of them. So virtual DOM is used in React and Vue frameworks, and what it usually means is that when a change is triggered, the framework keeps an in-memory copy of the DOM, and when a new change appears in the DOM, a new version of the DOM is generated, and there is a process called diffing between the two, the old version of the DOM and the new version of the DOM. And the result of this diffing process is a set of update instructions for the DOM. The problem with this is really efficient and fast, and that's why both Vue and React are really fast when it comes to change detection in our apps. But virtual DOM has one downside when it comes to memory, and the fact that each time a change occurs, you have to regenerate this tree, and you have to calculate the differences. And of course, there's a really highly efficient and optimized algorithm to do this, so it's not necessarily a problem. But there is this downside of the memory footprint when it comes to virtual DOM. On the other hand, incremental DOM has a different way to approach this, in the idea that it actually generates instructions to create the DOM node, which is done the first time, and then when something else changes, it has, because it knows that we have a binding here and an interpolation there and an attribute binding somewhere else, we actually know the places in our DOM where changes can occur, right? So we don't need to regenerate the whole DOM. We actually need to run a specific instruction when specifically that part of the code changed, right? So that's what happens when, if we go back to here, to this code example, when a change occurs in the position one of the title, and of course Angular is keeping track of these changes. It always knows what was the old value, it compares it to the new value, and if something changed, all it needs to do is actually just run this line of code over here, and that will update only this part of the DOM, and everything else can actually stay the same. So it actually has a fixed instruction set of everything that can change, where it can change, and it can handle that. So it doesn't need to figure out where the change is, because it knows exactly where the change is, right? So that's the main difference between incremental DOM and virtual DOM, and that's why Angular isn't using virtual DOM. It's actually using something different. It's not necessarily better. I mean, it is better from a memory footprint, because this tree is not generated each time. But in terms of speed, it's definitely not conclusive if this approach is better or not. Another thing that I told you, and I want to touch upon, and I'm almost done with the presentation, and then we'll have some short demos, is the notion of locality. And the thing is that Vue engine, so the old rendering engine, needed to have, because the way the engine is written, needed to actually have a global static analysis of the entire application, including your libraries, and so basically everything used in your code, Angular needed to know beforehand. In Ivy, this is different because of the way the components are written, and the fact that components only depend on their own factory for information that they require to render and to change detection. Any change that we do on a component doesn't need to affect the whole application. So basically, this is a big improvement in recompile times, because beforehand, if you change something in an Angular app, the whole application needed to be recompiled, of course with some optimizations. But now, because everything is local and each component is sufficient in itself, this will not trigger a recompile of all the dependencies. And let me give you an example of why that is. So if we look at a component that has this template, right? It has a div, a span with a title binding over here, and then another a child component that has a binding to the ngIf directive. ngIf, for those who don't know, takes a Boolean expression, and if the Boolean expression is false, removes this component from the DOM, and if this is true, we'll add it. The way View Engine used to compile this code was that at some point over here, right, you had these two right, you had a link to this template. So if you used this directive in your code, this directive was actually referenced, directly referenced in your code. Just a sec. Oh yeah. So this right, this directive was directly referenced in your code, and because this was actually directly referenced, sorry, the dependencies of ngIf, right? So if you have a look at the component on the Angular repository, what we can see is that the ngIf directive over here has two dependencies, right? This using dependency injection has two dependencies, right? The vContainer ref and the template ref, which means that the our component actually had had dependencies on the ngIf's dependencies, right? That's the way it was written. So that's why if something changed, you actually needed to compile everything else, because there were all these references. So because if you did a change, for example, in vContainer ref at some point, or in the ngIf directive, you needed to recompile the our own component as well, because you had these connections. You already had these connections, right? So because everything was linked together, everything needed to recompile, because everything was so tightly coupled. In Ivy, and with the introduction of this notion of locality, things look a bit different. And the idea that now we know that we have like a so now we don't have we just say that for example in our code, we just say that hey, we have a child we have a child component over here, which is this component over here, and it has it has a dependency on ngIf, but that's the that's the whole story. Like, we don't care about what this ngIf over here has for dependencies itself, right? Because the ngIf directive, because as I said, like, everything has all the information that it actually needs, right? We don't couple the dependencies of ngIf with the dependencies of our component. Like, yeah, I know I didn't do a good job of explaining this, but what you need to know is that because we don't have these references here anymore, this code over here doesn't need to be affected. Doesn't need, I mean, if we change something in the ngIf directive, we don't need to recompile this this component as well. Like, this will when this will run, it will go to the ngIf definition, and it will create the latest version of the ngIf directive. Like, we don't need to recompile this component as well. So that's awesome. And this also like, I felt it in the projects I'm working on, the fact that the speed of recompilation of the project is bigger. Okay, so that was a long long introduction in what Angular Ivy is about, and I'm going to show you like I still have like a couple of quick demos I want to show you, but just so I can catch my breath for a couple of minutes, if there are any questions so far that I can answer, just unmute and fire away if there's anybody there still there left.
I think people are shy a bit.
I mean, I know I didn't, you know, I didn't manage to explain everything to the full extent, but yeah. Okay, I can actually, you know, go ahead with the.
I can ask a question. Like, for
yeah,
example,
sure, please.
What are the performance benefits between Angular 8 or 9 or something like that? Like performance of, like, for example, how fast the application loads or things like that.
Yeah, as I said in the beginning of the presentation, you probably, so Angular is, as all the major front-end frameworks, is fast. Like it's you know, the average application, if you're not doing something like rendering thousands of lines in a table or whatever, like the average application is pretty fast. Like if you follow some good guidelines and some good standards, and you know, don't do crazy stuff, and there's, you know, some pretty simple things you can do and or not do in your applications to keep them fast. Like Angular is fast. Like I don't think Ivy, the main purpose of Ivy was not to make Angular faster, because Angular was already faster, and there's like a ton of things you can do to improve performance. Like you have the you know, you can limit the number of times Angular does change detection by modifying the strategy. You can lazy load code in order to you know, load parts of, you know, load the application faster, because not all the code is there. You will load code when it's required. So speed, I mean, there are some speed performance, but Angular was speedy before that, because the outputted code, even in the template compiler, the first version of the renderer, the JavaScript code emitted was really highly performant JavaScript. So that's why Angular was fast. What actually you know, what the main concern of the team was that they wanted to make the code simpler, and I showed you that, you know, things look simpler compared to the older version. Make the code smaller. Like that was I think the biggest problem of Angular applications is the code size. Yeah, and I highlighted I had like a slide with this. Yeah, make bundlers smaller, make compilation faster. Like that's the faster part here is actually the development part that is faster. Like you will see some speed improvements in Angular, but not I mean, like it won't run twice as fast or something like that, because it's already running pretty fast, right? And simpler. Like those were the actually the objectives, right? So in terms of working with Ivy, like I can or in terms of ease of debugging and figuring out what's wrong, and the framework actually helping you out when there are problems, and not making the problems worse by giving you cryptic messages and stack traces that are pretty difficult to follow. In that respect, you know, Ivy is doing, like the Angular team did a pretty good job with Ivy. And I'm not sure if I answered the question.
Yeah. What I was thinking is that, like with the new engine, like incremental DOM and also like smarter diffing, I was thinking that this also brings up some performance improvements in the way that the app reacts and the app loads and things like that.
Yeah, for sure. Like Angular used incremental DOM even from the beginning. So it's not something that they introduced. Maybe I didn't make that super clear. It didn't introduce incremental DOM in this version. It actually used it ever since the beginning. It's just a different way. Like the difference between virtual DOM and incremental DOM is not. I mean, it's not. Conclusive, and it's not necessarily like a way better approach. It's just different. Like virtual DOM is pretty fast as well, and there's a lot of optimizations you can do in virtual DOM, like to skip. You can skip, parts of the tree completely. To like, you can do all sorts of optimizations there, like to skip parts of the tree from checking, and so that's why I'm saying that it. This is not where the if there are any significant speeds improvement, it's not necessarily from IVs, from like general bug fixing and doing a good work throughout the years by making Angular better and better. But I haven't seen, like, I work with I had an Angular 8 project ported to Angular 9, and I didn't see, like, speed-wise, I didn't see like a lot of improvements. But I did see as the other as I showed in the beginning, I did see a decrease in bundle size, which makes the app faster to load. So if that's one metric.
Yeah, thanks a lot. Makes much sense.
Yeah, and as I said, like, this is still is, and it's still something that the Angular team is trying to figure out in terms of the bundle size, right? Because you have like incremental, and using incremental DOM, you have to create all those instructions for components. And I showed you a simple component now, but your components will have tens of, hopefully not hundreds, but tens of codes of line of template, and those means like hundreds of instructions per component, and you can have hundreds of components, which each with hundreds of instructions. And so that's why the footprint, the memory, the initial memory footprint might be larger in terms of space. That's why the bundle is bigger. But on the other hand, it won't take up as much memory to figure out change detection as virtual DOM, right? Because you don't generate the whole DOM again, and you just you know exactly. Yeah. Any other questions?
Thanks.
Okay, thanks. Great question.
How much did your app decrease in size when you upgraded to Angular 9?
Oh, not much. It was a pretty small size. So this is the part where this slide actually to answer your question, like, not that much, like somewhere around 10%. But this is why this slide over here makes much sense, or more sense now. Medium apps, so small apps. Let's take it from the beginning. Small apps will benefit from IV because you will have a smaller set of needed instructions, because you're not using all of Angular's features. You will have a smaller app because if you're not using features, they will not get shipped to the browser, as opposed to the older one, which shipped everything because it couldn't know beforehand what you were using. So that's why small apps will see a decrease in size. Like for me, it was a small app, but I didn't see like 30%. I saw something like 10%. But on the other hand, I showed you tweets from people that had like even bigger reduces. For large apps, it also makes sense because the instruction set, the generated instructions are smaller than the older render engine. So that's why larger app will also benefit a lot from IV, because they have hundreds of components, and then at hundreds of components, less and less code for hundreds and hundreds of components means in the end a smaller bundle size. You probably won't see in medium-sized apps, so apps that have like tens of components and use most of Angular features anyway, they won't see such a big improvement, right? Because it's not, I mean, they will still get most of the runtime shift to the browser, right? Because they need that to run the app, and there aren't that many components to fill the lines of code that have been, or like the number of characters, let's say, that have been reduced, right? So that's why maybe now this makes more sense. And it actually, I should put this graph at the end. It makes more sense after everything I told you, maybe. Yeah, so I didn't like, that's why I didn't see like a big reduction in size, but I have heard from people, like I heard, to be honest, I've seen tweets of people that said that actually after Ivy, their bundle sizes increased. So there's that as well, but those are rather the exceptions. Like most of the time, from what I've read from people, is that they got from minor improvements to big improvements with Ivy. So across the board, people are pretty happy with what they're seeing in Angular. With, of course, like, you know, some exceptions here and there. That depends on each application, but most people are pretty pleased. Yep. Does that answer the question?
Yeah. Thanks.
Okay. Any other questions before I go to code? Okay, if there are not, if there aren't any other questions, I'll go ahead and I will close this. I will maximize this just a sec. Okay, we have the app running over here. Sorry, I'll try not to go switch from screen to screen. I know it's not pleasant. Okay, so we're gonna play with the things that I'm gonna show you now are things that are still experimental. So I'm gonna use some internal APIs of Angular, but I want to show you what is where Angular is headed and what are some of the things that you can actually do in Angular 10, 11, 12, whatever. But I'm trying to show you where Angular is headed. So most likely everything that you'll see from now on is not, I don't recommend to use it in production or anything. It's internal APIs, private APIs that will most likely change, but the principles are there. And as I said in the beginning, Ivy is an enabler, and some of the things that I will show you now, maybe I'll do another presentation, a year from now, and I will show you the actual official APIs. So take what I'm about to show you like with a grain of salt, but still for me is super, super exciting. And it's stuff that you couldn't do, or it was super difficult and super hard to do before with earlier versions of Angular. Now with Ivy, it's actually a piece of cake to do some of the things. The code repo is Andrei is it's in the presentation. You can check it out. All the examples are there. So one of the things that I will show you is how to do moduleless, even moduleless applications, but moduleless components and zoneless change detection. I'll talk about each of them. So okay, don't save. Okay. So I'm gonna go ahead and so this is the main entry point for every application. So every Angular application. Well, not every application in the world, but every application that you start from the CLI. And what you need to do in an application is bootstrap a module. And a module. Let me close this. And a module actually has a component that is specified as being the bootstrap component. Basically, this is the root component of your application, right? So if you have a look at this component, you can see that the selector is app root, and if we look at the index HTML, you can see that this is where that root component will will get inserted. And of course, then that root component has child components, and they get rendered, and so on and so forth. But this is the main entry point of the of our application. So what I'm going to do, I'm actually going to comment this code, and I'm going to use a method which is called theta render component. The theta over here, the theta, I don't know like what was the correct pronunciation. This theta over here signals the fact that this is still experimental and private private API. But we can use this render component method over here and say that, hey, I will render the volume component, which is the component that you saw earlier with the up and down. And I'm going to say, okay, I want to render this component in app root, right? So if I go back to this component, as you can see, the component was actually rendered in our application. So this everything we have here is not needed anymore. Like this is basically a one component application without a module. Like this is something I wish, like I've been teaching Angular for quite a while, and I'm always frustrated with the fact that there's like a lot of stuff I have to explain before we get the first application run. I have to explain about modules, about component, and I wished that things were like, for example, in React, you have like one command that you run, like the render create component, render, what's it called? Create direct app, yeah. That like you have, it's pretty similar to what you have here. You have that, you just give it the simplest component you can imagine, and that's it. One line of code plus a couple of other lines of code in the component, and that's it. You don't need anything else to understand. And this is something that will be enabled in the future in Angular. So basically, we don't need a module to bootstrap our application. Now, because we don't have modules, we also don't have change detection. We also don't have other stuff in our you know, for example, if our volume component use some dependency injection and so on and so forth, we couldn't use that. So modules are important for a couple of reasons. First of all, they offer a compilation context. So for example, if the volume component template uses another component in its you know, in its template, the fact that the component is part of a module together with other components, that gives it the template and the compiler a compilation context for the template. So it will know where to look when it you know, when it sees something like custom, when it sees something like custom component, right? And it's something that it's not HTML specific, it will know where to look into that compilation context. So doing something like this will render the component, but we have like a lot of a lot of downsides. Now, I will leave the component. I will leave the app as it was before, right? So with the title and okay, and I will go in my app component. Right, I will go in my app component, and I'm going to try to fix some of the problems that that I showed you earlier. First of all, yeah. So I'm gonna say again here, render component, and I'm gonna say volume component. Yeah, so the app module component, as you can see, has the volume component, added in the declaration array, right? We need to, every component that is rendered in Angular, like before Angular 8, needed to be declared in a module in the declaration. And you know, I won't go into you know, very big details, but because the component is in the declarations array of a module, that means that it's available to be used in other templates. Right now, we remove the volume component from the decoration, so now it's not available it's not available anywhere in our code, and we're gonna actually render it using this host using this render component method, right? And we're gonna use this app volume. And in order to not, like we get an error now, and it's telling us that it's not a known element, and we can quickly fix that by saying schemas, no error schema, right? And now we tell Angular that, hey, if you can't find something in your template, like don't worry about it, and the error should go away at some point, and it went. Right, so the Angular won't bother trying to compile app volume component. It will just leave it. It will just leave it as as a regular tag. So now we render this component right again, and again you can see that the component was rendered, right? If we comment the code, right, the component is not there. So what we just did, we actually rendered the component without that component being available, without being available in a module, right? So for those of you who work with Angular, you know that this is already something super awesome. You don't have to specify that component. You don't have to specify the component in a module, right? So save, and it's here. Okay, but because the component is not in a module, another thing happens. Like we don't have access to the change detection mechanism in Angular. Angular uses for its change detection, it uses something special called zones, which tell Angular when to run. It's not part of change detection, but it's used to tell Angular when to run change detection. And because this component is not included in the module, it will not have any of the benefits of doing change detection. And even like if we go into the in the component and we log like volume up, and right, we see that the handler is called, so this works exactly. Just change detection isn't run. So what we can do is actually call detect changes, right? And we add it at the end. Detect changes needs to be right. We need to detect changes on this. This in this scenario is the component, right? And we added here as well. Right, and now everything works as before, right? So we just added 2 manual triggers to change detection. Okay, another thing that happens is when we add if we add, for example, setting service, right? So for example, we have like a lot of magic strings over here. So maybe we want these to be configured from someplace else. For example, from a service that we can easily modify. Okay, right. If you want to use this, we will get like a very big error here saying that right, we don't have we can't use the dependency injection mechanism because the component is not part of a module. We also don't have a dependency injection context, and we also need to add this here and say injector is say const equals and we'll use another special method, and this time it's with a double theta, so you know that this is really private, and it's called directive inject. Directive inject, we can inject the injector token, Right, and now we can actually use, so this actually gives us, this directive inject actually gives us a given token from the injectors, and the injector is actually the token responsible for giving us the current injector for this component. So we get a hold of that injector and we pass it into the newly created component. And now, yeah, everything works except for the fact that let's see. Anyway, the percentages are messed up. Anyway, so what we did, we created, to sum up, right? We created app component, right? We added a component to our code without included it in any module, but we needed to do this special trick where we added right, we added we needed to add the injector and do these special things with you know, to manually handle change detection, right? So these were the things that we needed to add. So this is you know, one of the things that can you know, be awesome to explore when it comes to you know, when it comes to Angular. Actually, I'm gonna because it's getting pretty late and I don't want to write all of this down. I'm actually gonna check out and I'm gonna explain real fast. Okay. 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 So another thing that we can do, or another thing that Ivy opens the because we have all these you know, all these methods that we can use. It opens up another interesting perspective in terms of you know, not using zones in you know, in our in our application. And Zone.js is a polyfill that we use for you know, for change detection, right? It's included here in every bundle, and it's usually, it takes like yeah, 50 kilobytes or you know, 60 kilobytes or 50 kilobytes when we gzip it. But if we eliminate it, we can actually eliminate it, you know, to squeeze a couple of more kilobytes from our bundle size. We can eliminate it and also tell Angular that we're not going to use ngZone, and that means that now we need every time we have a change in our application, we need to specifically tell Angular that, hey, something changed in our application. It's more or less how you would do things in React, for example, where each time state changed, you need to call set state, right? So React doesn't do automatic change detection for you. You need to specifically tell it, hey, something changed, right? So in order to do this, there's another method we can use, which is called mark dirty. And mark dirty what tells Angular that, hey, something happened in my component, something changed in its state, and I need you to run change detection on this component. And for example, I added a method here that, for example, when we reload the app, I added an interval that for 3 seconds increases the volume of the application, and we'll see that this will
right? This will not work, although the method is called, right? And the property is modified, right? The volume is increased. Angular has no way, because we eliminated zones, right? And Angular will not be automatically, called when, so the change detector won't be automatically called by zone when some change occurs. This will not, change the code. So what we need to do is each time we do, each time we do a modification, we need to use some kind of method. The old way you can do this, so this is not something you couldn't do before Ivy, you can actually use change detection ref, a service called change detector ref, CDR for short, and you can inject this and use the detect changes method or what have you. The problem is that in order to use this, you need to include the service, right? You need to add this, which makes it maybe more complicated when you want to test this component, because now you have to mock the change detector ref service and so on and so forth. So in order to because you don't you have now methods that are in the rendering engine, you don't need to add that service anymore. You can actually call these methods directly, which is a big improvement in terms of developer experience, because you don't need all these special services. You would just add this method. Of course, this is still experimental. We don't know if this is the way the Angular team wants to go when it comes to, but there definitely have been a lot of talks about eliminating at some point, or making zones as modules as well, like making zones not necessary for change detection. Okay, moving on. One of the other awesome things that you can do with Angular, and is now enabled by Angular, is the ability to lazy load components. You could up until now you could lazy load modules, right, based on the router. So for example, if you had a section of your application that you needed a certain role, or you needed to be authenticated in order to access, you can actually not ship that part of the code unless the user visits that route. So you don't need to ship all those components that are specific only for that part of the code, or for security reasons, you can actually guard against that part of the code being loaded if the user doesn't have access to a specific route. So lazy loading was actually built, I think, added in version 4 of Angular. So it's actually something you could do in apps pretty for some time now. But what you couldn't do, or what you couldn't do easily, like you needed like a lot of wizardry to do, was to lazy load components, like load just components without any module, without anything, just load a certain component when you need it. So the way you would actually do this, so normally what you would do in Angular 8, you would actually use the, I actually removed this. So there is a service called component factory resolver, and I know like this sounds so Java as a name, but yeah, bear with me. Actually, the code is actually pretty simple to follow. The namings are not necessarily friendly, but nevertheless, what you needed to do is actually create a factory for that specific component, and you needed to add a special a special slot in your template, which is you can localize it with this special template indicator over here, and you can say, hey, I want to create a component and move it in that put it spot. And you also give it an injector, and you triggered an initial change detection for that component. So you could actually do this. What you couldn't do is actually use the basic Webpack import statement, or like actually I think it's pure ES script syntax now, the import, to actually load the code for a component. And what you get in the end is actually the component code needed to render. So if you don't want to use the factory resolver service, you can actually just use the private or whatever render component method, which will render the component for you. So if we reload, and this is right, and this is just if we look at the template, we just have a button. Right now we have a button that when you click on it will load, will run this code over here, which is this code over here, which is a sync function, right? Because the import is returns a promise, we can use async await, and this import will return an object that contains a volume component as a property, and this volume component, if we log it, we will see now, right? So let me this. Yeah. So if we click on load component now, you should see. Sorry. You should see the loading, but clear. Okay. So, oh, it wasn't on all. No? Okay, what am I? Okay, so for some reason it's not loading. It's not loading the actual component. I mean, it's loading the actual component, but it's not lazy loading it. I don't know why. Oh, there it is. Okay, for some reason it didn't show up. So as you saw, this was which is the code specific for that component, right? Which is, yeah, something that looks similar, right? Element start, listener, text, whatever, right? So this actually like now becomes easier to read if you start doing debugging. Was loaded after the app loaded, right? After the initial app loaded. So this, opens up a wide variety of options. And I know you could do this, like this could be done in, I think in Vue, even in, I'm not sure if you could do this in React as well, but I know that, in Vue it was as simple as this code over here, and I think it works out of the box. So this is something that, Angular is playing catch up in some of these features, but this is something that we can do, like I'm guessing pretty soon. Now, of course, there's this whole discussion if this will actually bring you some super big improvement in terms of performance. Like in the end, you will probably save a couple of kilobytes maybe on this code, because this will get minified and uglified and everything. So this will be really small, and even your biggest components shouldn't be that big. So there's always the argument if this is an optimization you want to do, but nevertheless it's something cool that you can do now with Angular, and I wanted to show you. Okay, and the last thing, and I promise this is the last thing I will show you, is higher order components. Okay. So again, this is something that maybe could have been done in some ways in previous Angular versions, but it was more difficult, you know, than not. So what I'm going to show you really fast is an example of a higher order component for Angular that, for example, I have an observable here, right, that subscribes. So this is the higher order component. I'm going to comment it, and I'm going to show you what happens. So almost done. Okay. So what I'm doing here is actually starting that observable, which is an interval that runs indefinitely. So I'm actually toggling this component, right? So the component got destroyed, but the subscription kept on living because nobody unsubscribed to that observable. This is like the number 1, 2, and 3, and 5 up until 10 reason why we have memory leaks in our Angular applications. It's usually observables that people forget to unsubscribe. And this makes sense because you have to remember to write this .unsubscribe on your observables, which is something that you most likely will forget. Of course, it's recommended to use the async pipe. So that means that you won't need to manually subscribe to your observables. You can use them directly in your template, and Angular will take care of everything for you. But if you have to subscribe, it's actually pretty annoying to remember to put this unsubscribe. So what I did, I created a higher order component that will actually look in the properties of these our component, and if one of the properties is of type subscription, right? So the subscribe method actually returns a subscription object. It will unsubscribe when we destroy the component, right? So a higher order component, we can use it like there's many ways that we can there are like 2 ways we can do it. We can either use a decorator, right? A decorator, which is basically just a function that receives a class or a function or a property as an input and returns the same thing, only augmented or something modified on it. Or we can do something that maybe you're more used to from a React world or Vue world. So we can do like with unsubscriber and use this as a function, right? So remove this and put everything here in a function, or extract this as a variable and then use this. So there's like many ways you can do this. I'm gonna go now with the version that uses these decorators. And if we do like if we look at what the decorators looks like, I'm just like gonna comment step by step the code just to explain what it does. So a decorator, as I said, is a function that returns another function that creates that object and returns it in a modified way. If we leave the decorator as is right now, we'll see that we are in the decorator, like the decorated logged, but nothing changed. Like this is the most basic, useless decorator that you can do. Just receive the component and return it, right? This actually returns the class. And actually, if we have a look at how this component looks, sorry. Right, we'll see how this looks, right? And what it is actually what we got is this object over here that has 2 methods, which also are private. So these might change, and they actually did change from a version of Ivy to the next. But being private, it doesn't matter because they're not intended for the public. But you get this factory function, which is a function that is actually used to instantiate instances of our component, and then you have the component which has all the properties and things that are you know, belong to the component. For example, we have this input of type volume, right, which is the, right, if we look at the definition, it is exactly this input over here, right? So we have all these properties, all the how they're called, the lifecycle hook methods, right? So after view init and on destroy and so on and so forth. So you can actually see that on destroy is actually a function because we actually defined it. We actually defined it here, right? We have the on destroy lifecycle hooks. All the others are not. And John init is also there. So what we have at this point is an object that gives us the factory and the properties that are on the component. So what we need to find is we need to find our property. Just a sec. For some reason I can't see. What was it called? I have volume. Anyway, so what we're gonna do is we're actually gonna take, you know, we're gonna take the factory. We're gonna you know, grab hold of it, because what we want to do is actually create the component as is when it gets into the decorator. We want to add something to that already created component, and we want to return the new decorated component. So that's basically what we are doing here. That's why we're keeping track of the old factory, because what we want to do is actually create. Let me comment everything. What we want to do is actually create a new factory function that creates a component from the old factory. And on that, you know, on that old component that we, or like the component that we got as a as an input, right? This component over here. What we want to do is call the, you know, we want to add a special on destroy method. That what it does is actually it looks if the previous component had an undestroy method. It calls that undestroy ng undestroy lifecycle hook of the actual component, and it looks for properties in the component that are of type subscription. And what it does is unsubscribes from them when we call undestroy. So if we run this code now. Right, and we toggle, we see that the subscription is stopped, and we see that the component on destroy is called first, and then the higher component destroy is called afterwards, right? That's because we get a hold of the component, right? We call the already existing on destroy method on it, right? And on the new component, the one that we are returning, the one that we are modifying, right? We are creating a new method, a new on-destroy method that calls the old method and does something extra, right? We're basically decorating the component and the on-destroy method. So this is a really basic example of what we can do with hierarchical components. You can already imagine like a lot of scenarios that we can use hierarchical components for, like, you know, people that are accustomed to React or Vue, you know, frameworks that use heavily this notion of hierarchical components. You can already imagine. Like I saw a really awesome example. Let me, and this is the last thing. Let me see if I find it. Yeah, there it is. Like someone did with styles, like CSS, CSS, JS in CSS, or CSS in JS, right? With Angular, and it actually just did a decorator with styles. That what it does, right? The decorator with styles, what it does is actually, you know, the same idea. It captures the original factory. creates a new factory, and on the existing component, it adds the new styles, right? So what you do is you actually decorate your component with some styles, and they end up getting added to your component. Or you can add with theme, or I saw like, you know, some examples of hardware components that extract properties from the router, or hardware components are really like a really awesome pattern, and I'm pretty sure they will you know, land in Angular at some point in the future. Yeah, so yeah, that was about it. I actually hoped to you know, do more coding and less hacking, but it always with me it always ends up the other way around. Yeah, thanks for bearing with me. Sorry for staying like 20 more minutes, like a lot. You know, I think half the people already left, and I don't blame them. But for those of you who stuck around, are there any questions or anything else I can, or you know, if there are any questions?
Besides prototyping, what is a real use case for rendering your components as without inside a module, like modulus components?
Yeah, there's not, I mean, like I haven't, so I can, there's like a lot of scenarios where you want to dynamically load components in your application. Like you can imagine like a tab component where each time you switch a tab, you can load another component inside your tab view. If it is the case that you want, for maybe for security reasons, in that tab component, some of the tabs are not available for users that don't have a specific role or something like that. Maybe you want to lazy load that component and only lazy load it there if whatever security concern is you know, passed. That could be one you know, one scenario. Yeah, other than that, I don't know. In situations where you have like, you know, widgets, a widget-based dashboard, that can also be a good scenario where, you know, you have like hundreds of widgets in your code, and you don't want to load all of them. You just want to load a few, you know, the actual few that the user selected. Previously, you actually needed to add when you wanted to dynamically load components in Angular prior to 9, you actually needed to add them in a special place in a module. So that means that they will somehow get shipped with your code. I mean, okay, you can lazy load that module, and then, but still they were attached to a module. So for example, take the widget dashboard example. You have like 200 widgets, right? Each of them should be attached to some module, and one way or the other, they will get loaded even if you don't need them. With this new scenario of lazy loading components, if your user has only 5 widgets on his dashboard, you can lazy load only those 5 widgets and not load those other widgets unless the user adds them in your interface, right? That's an example. Does it make sense?
Yes. So lazy loading component is does it require you to use the modulus thingy that you showed?
And so there's actually, you can do
the two.
Yeah, so you can do lazy loading for components already by using the let me see if I still have the code here. No, I removed it. Well, you can still use the
import syntax, right? Using the
you can use, you can already, that's the thing that Ivy enables. The fact that you can use the import syntax, and the fact that because the component now is because of locality, so that when you import the component, it already has everything it needs, right? It's you don't have to include it in a module. Like the component already knows everything that it needs, and you can use the old way of doing things with component factory and so on and so forth. What you need to do, to be careful though, is that component, because it's not in a module, doesn't know about components around it. So if it uses some kind of, child, it has child components and things like that. That's one of the things I didn't show you because, it could have gotten into a really complex discussion. And I'm still not sure how the Angular teams, how the Angular team thinks about solving this. That's why it's still experimental. Is a way to tell your component, hey, you're going to use these other components. Right, because now the component not being in a module doesn't have a compilation context as the other ones have, right? So that's one of the problems. You can do it. I mean, you can make a higher order component that you can specify. Hey, you can use these components here. Like my volume component will use the whatever. I'm out of inspiration right now, but we'll use component 1, 2, and 3. Right, and you can specify them, and they can be attached in the definition of the component, as I showed you in the factory or someplace else. Right, there's a special place where they get declared. But you need to, now you need to do this manually. Right, so it's not. You need to be aware of this.
Yeah, got it. Thanks, man.
Yeah, sure. But there's like a lot of scenarios. Like I'm looking forward to see how people use this. Like I've seen another example with exposing lifecycle hooks as observables done with hardware components as well. Like ngSE, I think. No, GitHub. Sender or SEMG. Anyway, there's this. Okay, I can't find it right now. But there was this guy that did higher order component for that allowed you to specify lifecycle hooks as observables, right? And you had them as properties on the class. So that's also some awesome. Like I'm looking forward to see what people do. I also saw a really good presentation at some point. Somebody talking about doing something similar to the set state hook in React, but with higher order components for Angular, right? Because right now Angular doesn't have like the same dynamic as React does with is a component that have state, right? So you only have like properties of the class. You don't have actually the component itself doesn't actually have internal state. It just has the properties of the. Yeah. Okay. Any other questions or curiosities or?
Just a side note.
Yeah.
We have a repo where usually after each meetup we gather all the slides, the information, everything we talked about.
Yep.
It'll be available to everybody in the following days. So if you're not familiar with our repo, you can visit GitHub JSHeroes and you'll have the meetup repository. And hopefully in the following days it will be up to date with everything that Andrei presented and the slides if you want to share them, and of course everything.
Yeah, sure. As I said, like the slides are the beginning. Yeah, they're pretty simple to add, and the repo is like my name / Angular IV experiments. But yeah, you'll have the presentation with every resource. Okay. If there aren't any other questions, yeah, I want to thank everybody for staying this late with me. I know it's been like a really long presentation. The thing is that it's something I'm really passionate and excited about, and that's why I tend to like talk a lot about it. There's like there's like still a lot of stuff I haven't I haven't talked about. But if you don't work with Angular, or even if you work with Angular, what I can say is that the future is pretty, it's looking pretty good, and there will be some pretty exciting stuff coming with Angular in the next, in the next releases, and I'm really looking forward, and I really trust the team that's taking care of the framework to, make it better and better, release from release.
Thank you, Andrei.
Thank you.
Thanks, man.
Thank you.
Have a great evening, everyone.